imagine spending something like $300 million on the most advanced invisible stealth fighter ever built. You put it on the runway, fully fueled, the weapons are loaded. But then when you try to start the engines to defend your borders, you realize the allied nation who sold you that jet just hit a remote digital kill switch.
Wow. Yeah.
And your entire Air Force is permanently grounded. And, not a single shot has even been fired.
Which is, that is the ultimate nightmare scenario for any modern defense planner. And the hard truth from the sources we're looking at today is that we are moving rapidly toward a world where that level of control isn't just, science fiction anymore. It's a structural reality of modern geopolitical warfare.
Right. Well, welcome to the deep dive. Usually when we think about upgrading our technology, we view it as a pretty linear path, right? Like when you go from a flip phone to a smartphone.
Yeah, exactly.
You get a better screen, you get a faster processor, maybe a better camera. It's fundamentally the same basic thing, just more capable.
Which is a very comfortable way to look at progress, honestly. The user experience improves, but your fundamental relationship with the device remains completely identical. You're still just, calling your family or sending texts, even if the packaging happens to be a slick piece of glass.
Right, exactly. But imagine if, instead of just buying a better phone, your next upgrade required you to basically become the entire internet service provider.
Oh, that's a good way to put it.
Yeah, you're not just holding a device anymore. Suddenly, you have to physically build the cell towers, you have to lay thousands of miles of fiber optic cables, launch your own satellites, and manage data centers just to make a single phone call.
And that is no longer an upgrade. That is a massive paradigm shift. You're moving from owning a discrete product to engineering and operating an entire wildly complex environment. The scale of the challenge becomes almost incomprehensible for someone who just wanted to make a call.
Today, we're taking a look at a topic that fundamentally rewrites the rules of global power for you. We're digging into our source material today, excerpts from the Strategic Vanguard, and we are examining the global race for sixth-generation fighter aircraft.
Specifically looking at India, right?
Yes, specifically looking at India's intense struggle for aerospace sovereignty. Our mission today is to unpack why the development of these next-generation jets is no longer merely a military procurement issue. It's a civilizational, technological race. And whoever masters this race is going to dictate the geopolitical hierarchy of the 21st century. Keep in mind, we're just reporting what the analysts and defense experts in these sources are laying out.
Right, we're just analyzing the text here. And the text makes it clear the paradigm of air combat has entirely shifted. If you take away only one thing from our discussion today, it should be this global race is not about building a faster airplane.
It's really not.
It's completely disconnected from creating a sleeker airframe or a more powerful gun. It's about building a vast, integrated combat ecosystem. The aircraft itself is no longer the center of the universe.
Which is pretty wild to think about, considering how we usually picture fighter jets, right? If you're like me, you picture it Top Gun style.
Oh, yeah. Aviators and leather jackets.
Exactly. Lone wolves dogfighting in the clouds, pulling crazy G-forces, human skill against human skill. But to understand why the mission is now about building ecosystems rather than just cool airplanes, we really need to trace how the definition of air power evolved to this point.
Let's contextualize that evolution, because the leap to the sixth generation only really makes sense if you see what came before it. So think of generations 1 through 3 of fighter jets as a race for pure athleticism.
Okay.
Right after the Second World War, first-generation jets were just about basic propulsion, like getting off the ground without a propeller. Then the second generation introduced airborne radar and broke the sound barrier. And then the third generation pushed that even further, focusing heavily on raw maneuverability and shooting missiles over the horizon.
So pure brawn, just who can fly higher, turn faster, and shoot further.
Exactly. Brawn. But with the fourth and fifth generations, the paradigm completely shifted from brawn to brains. Fourth-generation fighters introduced something called fly-by-wire.
Which is what exactly?
So instead of a pilot pulling a stick connected to physical cables that literally move the flaps on the wings, computers translate the pilot's movements into electronic signals. It made the jets incredibly agile, essentially relying on computers to keep an aerodynamically unstable plane in the air.
And then we get to the fifth generation, which is where the top-tier militaries of the world are operating right now, right? We're talking about aircraft like the American F-22 and F-35 or the Chinese J-20. This is where stealth comes in.
Stealth, yes. But more importantly, a concept called sensor fusion. Before this, a pilot had to look at a radar screen, an infrared screen, and listen to radio chatter, trying to piece the battle together in their own head.
Sounds overwhelming.
It was. Sensor fusion takes all that raw data from satellites, wingmen, internal sensors, and the computer paints a single, easy-to-read picture. The plane became a localized intelligence hub.
Okay, let's unpack this. If the 5th generation is a flying intelligence hub, what actually defines the 6th generation? Because reading through our material, it sounds indistinguishable from science fiction. I mean, the jet is no longer this solitary hero. It's basically just one node in a much larger interconnected network.
Yeah, the philosophy of combat changes entirely here. A 6th generation fighter is less of an airplane and more of a heavily armed server rack.
What flying server rack?
Basically, we're talking about a system defined by artificial intelligence-assisted combat management, manned-unmanned teaming, and quantum-resistant communications. And the ultimate goal of all of this tech is a military concept called decision superiority.
Let's pause on decision superiority for a second. If I'm listening to this right now, I'm probably wondering what that actually looks like in practice.
Sure, let's walk through a scenario. In the past, if an enemy fired a missile, a pilot had to physically see it, recognize the threat, decide on an evasion tactic, and deploy countermeasures. That takes seconds.
Which is a lifetime in the air.
Right. In a 6th generation ecosystem, the sensors detect the launch. An onboard AI instantly calculates the missile's trajectory, talks to a swarm of autonomous drones flying maybe 5 miles away, commands one drone to jam the enemy's radar, and commands another drone to physically intercept the missile.
Wow.
And all this happens in milliseconds, far faster than the human pilot can even blink.
So the human brain literally becomes the bottleneck.
Precisely. Decision superiority means winning the war by processing information and controlling the electromagnetic spectrum faster than the enemy's computers can even comprehend what is happening to them. You overwhelm their algorithms before you drop a single physical bomb.
Here's where I want to ask a practical question. If the physical jet is now just this, flying battlefield management system, does the raw speed or the turning radius of the aircraft even matter anymore compared to its computing power? Like, if it's just a node orchestrating drone swarms, do we care how fast it can do a barrel roll?
Well, what's fascinating here is that the physical attributes of the aircraft still matter for survival if you get cornered, but they're entirely secondary to the digital capabilities. This is a crucial distinction made in the source material.
So the software is more important than the hardware?
Essentially, yes. Failing to build the supporting digital ecosystem, things like a secure cloud combat architecture and absolute semiconductor resilience, means a nation does not truly have 6th generation capabilities, even if they somehow manage to build or buy a highly maneuverable radar-invisible airframe.
Because without the ecosystem, your supersonic stealth jet is just an expensive blind target.
Without the sensors, the AI, and the data fusion, it really doesn't matter how stealthy you are. The shift is firmly away from kinetic warfare toward algorithmic dominance.
Which is a deeply sobering reality for any military planner. And since dominating the 6th generation requires this massive digital and industrial ecosystem, we have to look at the two superpowers currently capable of building them. This really puts the sheer scale of the challenge for the rest of the world into perspective. Let's start with the United States. They have a program called NGAD. Right.
Yes, the Next Generation Air Dominance Program, or NGAD. It perfectly illustrates this ecosystem concept. NGAD isn't just a blueprint for a new fighter jet. It envisions a highly secretive manned aircraft operating alongside a whole fleet of autonomous collaborative combat drones.
The loyal wingmen.
Exactly. The military often calls these loyal wingmen.
And these loyal wingmen aren't just tagging along to carry extra missiles, right? I mean, they are an extension of the system itself. They might fly far ahead to conduct reconnaissance, run electronic warfare to blind enemy radar, or even act as sacrificial decoys to absorb incoming fire and protect the human pilot.
Right. The human pilot is no longer a traditional dogfighter. They become a mission commander sitting safely at the center of the network. That setup heavily leverages America's existing decades-long advantages in network-centric warfare and software development.
But it's not cheap.
Not at all. The costs associated with engineering this reality are staggering. We are talking about estimates of hundreds of millions of dollars per single manned aircraft. The industrial complexity is expanding so rapidly that supply chain sustainability and production timelines are becoming massive hurdles, even for a defense budget as astronomically large as the United States is.
But America's massive spending isn't happening in a vacuum. It's a direct reaction to what's happening across the Pacific. I mean, China didn't just wake up and decide to build a new jet. They looked at the entire board.
Yeah, China's evolution over the last 20 years is unprecedented. For a long time, the global assumption was that China would simply rely on reverse engineering, acquiring foreign technology, and, imitating Russian platforms.
And they did do that for a while.
They did. But that era is effectively over. Today, they aren't just building advanced planes like the stealthy J-20, they're utilizing a strategy of complete state coordination.
Here's where it gets really interesting. We see the term civil-military fusion brought up constantly in the sources when discussing China.
Because it is the engine of their ecosystem. In the West, you have a somewhat clear divide between commercial tech companies and defense contractors. In China, that wall simply does not exist.
Right.
A breakthrough at a commercial artificial intelligence startup, or a quantum computing lab, or even a commercial drone manufacturer is legally and systematically funneled directly into the military-industrial base.
That structural difference is fascinating. When you really look at it, America's biggest fear outlined in the text isn't necessarily China's specific aerodynamic designs. It's China's immense scale and its sheer speed in mobilizing national resources. They aren't just trying to build a better plane, they are mobilizing to dominate the future industrial order itself, like AI, space systems, advanced manufacturing.
Which is why this is a civilizational race. China is not simply trying to match the West platform for platform. The sources indicate it is actively attempting to reshape the entire balance of power in Asia. Future conflicts won't begin with a sudden dramatic missile strike.
They'll start way before that.
Right. They will be shaped by surveillance dominance, electronic warfare suppression, and aerospace intimidation long before a single kinetic shot is fired. If China achieves sustained aerospace superiority through this ecosystem approach, they can dictate terms across naval operations, border disputes, and regional influence without ever formally declaring war.
So if it's essentially a two-horse race right now between the U.S. and China for building these massive multi-trillion-dollar ecosystems, where does that leave a nation like India? Because India is a massive nation, it has a massive military, and it is a regional powerhouse in its own right. But they find themselves in a highly precarious position here.
Yeah, India's historical reality has been one of deep dependency. Their fighter inventory has relied heavily on imports for decades. I mean, they've operated Soviet MiGs, Anglo-French Jaguars, French Mirages and Rafales, and Russian Sukhoi.
A real mix of platforms.
Right. And even when they have pursued indigenous programs to build their own jets, they've often depended heavily on foreign suppliers for the most critical internal components.
And right now, India is putting a lot of weight on something called the AMCA, the Advanced Medium Combat Aircraft Program. This is their planned fifth-generation stealth fighter. But it's not just about getting a new plane onto the tarmac, is it?
No, it is a critical national test. It's a test to see if India's state-run strategic industrial structure can actually build an ecosystem that scales. We're talking about organizations like DRDO, who designs the defense tech, and HAL, who actually manufactures the aircraft.
And that test is currently exposing a massive, persistent core vulnerability for India, the jet engine. The jet engine is often referred to as the crown jewel of aerospace engineering. Very few nations in the entire world, essentially the US, Russia, France, and the UK, with China rapidly catching up, truly master it.
It is incredibly difficult to build.
Wait, I want to push back on this narrative for a second, because this is a paradox that a lot of people struggle to wrap their heads around. Think about India today. They have an enormous, globally respected software sector. They have a booming tech talent pool, massive tech startups, and engineers leading some of the biggest companies in Silicon Valley. So why have they historically struggled so much with the hardware side of this equation? Specifically, why is a jet engine the thing that trips them up?
That is the multi-billion-dollar question, honestly. And to understand why India struggles with jet engines, you have to look closely at the physics. Writing advanced software and forging advanced metallurgy are fundamentally different disciplines with entirely different developmental timelines.
How so?
Well, think about the environment inside a modern military jet engine. The temperature inside the combustion chamber actually far exceeds the melting point of the metal used to build the engine itself.
Wait, that shouldn't be physically possible. How does the engine not just melt into slag?
Because aerospace engineers have to design these microscopic, incredibly precise cooling channels inside individual fan blades. And those blades are spinning thousands of times a minute under immense centrifugal force while blasting superheated gas.
That's crazy.
Yeah, you have to engineer materials that can survive that environment reliably for thousands of hours. You cannot iterate that overnight. Software can be debugged and updated with a patch in an afternoon, but hardware, especially operating at extreme temperatures and pressures, requires generations of institutional knowledge, trial, error, and immense capital.
So it's not a problem you can just throw money and coders at.
Yeah. Not at all. If we connect this to the bigger picture, it requires long-term strategic patience. You have to build the foundational sciences, material science, advanced forging, precision manufacturing. Aerospace power is built over decades of institutional continuity. It is never built through short-term political announcements of a new prototype.
And the sources point out India's past struggles here, right?
Right. India's historical Kaveri engine project faced massive setbacks precisely because of these metallurgical and engineering hurdles, leaving them dependent on foreign engines even for their domestically designed aircraft.
Which means, because they haven't mastered the physical engine, their entire domestic ecosystem is essentially held hostage.
Exactly. You could build the most aerodynamic airframe in the world, and you could write the most brilliant AI software to fly it. But if you rely on a foreign power for the engine that keeps it in the sky, they control your operational readiness.
They hold all the cards.
They do. They can threaten political sanctions, restrict export controls on spare parts, or simply disrupt the supply chain during a geopolitical disagreement. They can ground your entire fleet without lifting a finger.
Okay, but a skeptic might look at this and say, if building indigenous engines and tech from scratch is so painstakingly difficult and requires decades of trial and error that India might not have time for, why can't India just keep doing what it has always done? Why not just leverage their relationships and buy advanced sixth-generation systems from allies like the US or France?
Because in the sixth-generation era, buying hardware means buying a locked digital ecosystem. Military imports might solve an immediate capability gap today, but they create deeply structural, long-term vulnerabilities tomorrow.
You know, this reminds me of a debate happening in the agricultural world right now. It's honestly like buying a high-tech smart tractor.
It's a smart tractor. Okay, explain the connection there.
So think about modern commercial farming. A farmer buys this incredibly expensive GPS-guided, AI-driven tractor. It's a marvel of technology, but the manufacturer's software locks the engine. If a sensor breaks in the middle of harvest season, the farmer isn't allowed to just pop the hood and repair it with a wrench.
Oh, I see where you're going.
Yeah, they have to wait for an authorized corporate technician to come out with a proprietary laptop to unlock the code. They don't really own the tractor, they're just licensing the ability to use it.
This raises an important question, though. I'd take that analogy a step further, but with a much darker geopolitical twist. It's like the smart tractor, yes, but imagine if the manufacturer didn't just lock the engine. Imagine if they could remotely steer your tractor into a ditch if your country voted against them at the United Nations.
Oof, that is terrifying.
That is the level of geopolitical leverage a locked sixth-generation fighter gives a foreign supplier. Future warfare involves deeply proprietary software ecosystems. If India relies on imports, they risk software locks and electronic restrictions.
Right.
Imagine a scenario where India enters a border skirmish that their foreign supplier doesn't politically support. The supplier could simply withhold the critical network updates or cryptographic keys needed to turn the radar on. In a crisis, if you buy a foreign sixth-gen fighter, the supplier nation essentially holds a kill switch on your national defense.
Which really highlights the broader geopolitical consequence of this entire technological shift. The world is actively splitting into technological blocks. You have the US and its tightly aligned tech ecosystems. You have China aggressively exporting its digital infrastructure to emerging markets. And then you have Europe desperately pursuing its own strategic tech autonomy. Technology itself isn't just a tool anymore. It is geopolitical territory.
It is the new high ground. Semiconductors, artificial intelligence algorithms, space-based communication infrastructure, these are all explicit instruments of national power. To be a great power in this new reality, a nation cannot permanently remain import-dependent in critical strategic technologies. Eventually, sovereignty requires creation, not merely acquisition.
So, if India can't just build an entire sixth-generation ecosystem from scratch tomorrow, but they also can't afford to be locked into someone else's smart tractor ecosystem forever, what is the actual solution here?
Well, the solution outlined by experts has to be a deeply pragmatic, layered approach. India must pursue selective co-development partnerships. This means actively working with nations like the US or France on joint research and technology transfers. But the critical distinction is using those partnerships to accelerate domestic learning, not to permanently replace domestic capability.
You learn the mechanics of the engine from the partnership so you can eventually build your own.
Correct. And that strategy must be paired with massive, sustained domestic investments in artificial intelligence, fostering a robust private defense sector, and building semiconductor resilience at home. It requires a generational vision that outlasts 5-year political election cycles.
So, what does this all mean for you listening right now? Whether you are working in business, studying tech, or just keenly observing the shifting tides of global politics, the core takeaway from this deep dive is that 6th-generation fighter jets are just the most extreme, highest-stakes example of a much broader global reality. Relying entirely on external entities for your most critical infrastructure inherently limits your autonomy.
Yeah, and it applies to corporate supply chains just as much as it applies to national defense.
Absolutely. Power in the modern world is no longer just measured by the physical territory a country holds or the size of its population. It's measured by technological sovereignty. If you do not control the deep systems you rely on, the code, the chips, the engines, you do not truly control your own destiny.
That is the unyielding strategic reality of our time. And for nations like India, the urgency cannot be overstated. Technological windows of opportunity do not remain open forever. The nations that control the skies today, the ones who possess the institutional patience to build and master these 6th-generation ecosystems, will be the ones writing the geopolitical rules for everyone else for decades to come.
I want to leave you with a final thought to mull over, something that builds on everything we've unpacked today but wasn't explicitly covered in the texts. We discussed how future jets will rely heavily on AI and autonomous drone swarms to achieve decision superiority simply because human biology can't process radar data or missile trajectories fast enough. But think about the logical extreme of that philosophy.
Okay.
What happens when two opposing AI-driven 6th-generation fighter ecosystems, both operating at algorithmic speeds completely beyond human comprehension, encounter each other in a patch of contested airspace? If the human pilot is now essentially just a mission commander sitting back in the network, could an algorithmic miscalculation trigger a full-scale war?
That's a scary thought.
Could an automated electronic warfare system misinterpret a sensor ghost, launch a swarm response, and initiate lethal force before a human brain even has the time to recognize the error and hit abort? It's a chilling thought about the ultimate hidden cost of delegating our survival to machines. Something for you to ponder as the race for the skies silently accelerates above us. Thanks for joining us on this deep dive.
Thank you for joining us on this Strategic Vanguard podcast. If you found value in this analysis, don't forget to like, share, and subscribe to our channel. We bring you fresh podcasts every Monday here on YouTube and Rumble, and you can also catch the audio versions on Spotify and Amazon Music. Just search for Strategic Vanguard Podcast. For more insights, articles, and discussions, subscribe to our blog at strategicvanguard.com. Your support helps us grow and bring you more in-depth analysis on defense, geopolitics, and strategy. Until next time, stay informed, stay strategic.